We're so conditioned to see spider webs as, just these passive things. Sticky architecture built for one reason, to be lethal.
Right, a trap.
Exactly. But what if that silk wasn't just a trap? What if it was actually a communication network, buzzing with conversations we just can't hear?
It's a really stunning piece of biological engineering. For decades, we really did view the web solely as this sophisticated snare. But the core discovery we're unpacking today, it just fundamentally changes their view. Spiders use their webs not just to catch prey, but as these complex, actively managed communication systems.
So the silk itself is the medium.
The silk is a transmission medium, yeah. It's alive with encoded messages.
Okay, let's dive into this. Our mission today is to get into your sources on what some are calling the silent language of silk and really uncover the mechanics of it. How does a spider turn its web into, a network for dialogue?
Well, what's so fascinating is that it's not just listening. The spider is an active participant. It's engineering the conversation.
Okay, so we've always known spiders rely on vibrations, right? A bug gets trapped, the web shakes, the spider knows.
Right, that's the basic picture. A trapped insect creates one kind of signal, a potential mate creates another. But the recent science, it shows these vibrations are so much more sophisticated than just simple alerts.
So not just an on-off switch.
Not at all. They carry encoded information. This allows the spider to interpret exactly who or what is on the web and, crucially, where they are.
That moves the web from just passive detection to something much more like active communication. But for that to work, the receiving equipment has to be flawless. How does a spider tell the difference between, say, a struggling beetle and the very delicate approach of a much smaller suitor?
Well, the web amplifies the signal, but the real magic is in the reception. The spider's legs are equipped with these specialized mechanoreceptors and fine hairs that are just unbelievably sensitive.
So it's all in the legs.
Think of the silk strand as this enormous, finely tuned antenna. It's a complete extension of the spider's sensory world. They can perceive motion on a nanometer scale.
A nanometer scale?
Wow. Yeah. They don't need ears in the way we think of them because the entire web is their sensory organ.
And if the whole web is the ear, that implies some incredible filtering must be going on.
Exactly.
I mean, our sources mention species like the orb weaver. It can tell the difference between a gust of wind and another spider with near perfect accuracy. That signal processing that rivals our own digital filters.
That is a perfect analogy. It takes a massive amount of data filtering to get that kind of clarity. But what's maybe even more important here is that the spider isn't just reacting. The communication is intentional, it's controlled.
Okay, what kind of messages are we talking about?
Oh, warnings, territorial boundaries, or even explicit invitations.
But for it to be intentional, the spider has to be able to shape the signal, not just send a raw tremor.
It does, and this is where the research just gets incredible.
This is the tension modification part.
It is. Research from Binghamton University showed how spiders can actively modify the tension of their webs. They literally pull or press on the threads to fine-tune how vibrations travel.
Wait, so they're tuning it like a guitar string?
That's exactly it. The spider is an engineer. It's adjusting the physical properties of its own network to manipulate the speed and the pitch of the signal.
That is fascinating. It's like having an internet router you can just redesign on the fly to prioritize certain data packets.
Yeah.
So you can almost picture this silent conversation, can't you? One spider sends a little pulse, a specific rhythm.
And that vibration travels, modified by the tension the first spider intentionally set. The second spider feels it, interprets the pattern. Is this fast and high frequency, suggesting aggression?
Or is it slow, rhythmic, signaling a friendly approach?
Precisely. And it responds in kind, maybe changing the tension around its own legs to make sure its reply is perfectly clear.
And this back and forth lets them coordinate all these complex things, movement, defense, without making a single sound a bird might hear. The web is their own private, encrypted channel.
And this silent dialogue is very often a matter of life or death. The stakes are probably highest during courtship.
Right, because for mating spiders, sending the right message, well, it's the difference between mating and becoming a meal.
The male risks being instantly identified and consumed as prey. The evolutionary pressure to get your introduction precisely right is immense.
So what happens if he gets the rhythm just slightly wrong?
He becomes dinner. The male has to send these highly specific, species-specific signals. They're often rhythmic, complex pulses that the female has evolved to recognize as not food.
A very important distinction.
A very important one. And the female then responds with her own signals, either a welcoming vibration or a forceful, aggressive warning to back off. It's this whole negotiation happening entirely through vibration.
And it's not always just vibration alone, is it? I saw that some species, like jumping spiders, they add visual cues.
Absolutely. They use every medium they have. Jumping spiders are known for their vibrant color displays, their leg movements. It's like adding body language to the spoken word of the silk, a multi-sensory dialogue.
Which makes the message even more unambiguous. But this vibrational tech can also be weaponized for deception, right?
Oh, definitely. Spiders are excellent at recognizing the signature of their own webs, but they can manipulate that to trick others. The tropical orb weaver is a fantastic example of this.
They use a kind of acoustic manipulation.
Precisely. Researchers found they generate these complex rhythmic patterns to mislead flying insects.
How? What does that sound like to an insect?
It might mimic the low-frequency flutter of a leaf, or maybe the vibration of a web that seems old and abandoned. It basically tells the insect this is safe to land on.
And then ambush.
A perfect ambush. It's sonic deception. They're essentially generating fake news for dinner through physics.
That is just mind-bending. Okay, so let's shift to the bigger picture here. Scientists aren't just looking at this as biology anymore, are they? They're seeing it as a blueprint for data transmission.
They are. And what's fascinating is how they're studying it. They use tools like laser vibrometers.
What do those do?
They can measure the movement on the silk threads down to the nanometer, so they can map the entire conversation as it happens. And what they're finding are distinct frequencies and rhythms, almost like musical notes.
So spiders are composing symphonies of survival.
That's a great way to put it, yeah, through silk instead of air.
And the implications here, they go way beyond biology. Engineers and roboticists are looking at this, and it's challenging how we even think about moving data.
We're seeing a boom in biomimicry from this. I mean, why rely on high-energy electronic signals when vibration-based data transfer is so efficient?
Okay, give me an example. How do you mimic a spider web to make, say, a building smarter?
It's a field called structural health monitoring. If you embed vibration sensors into a bridge or a skyscraper designed to react to tension just like a spider web does, you can monitor the building's integrity in real time.
So instead of waiting for an inspection,
the structure itself communicates. It tells you about subtle changes, stress points, microfractures, all through vibrations. It's proactive, silent, and incredibly energy efficient.
A nervous system for infrastructure. That's incredible. And I imagine this applies to robotics too.
Absolutely. Think about soft robotics, where you want to avoid clumsy wiring.
Right.
Or developing silent communication systems for deep sea exploration. The lessons here are invaluable.
You know, all of this, it really challenges our assumptions about intelligence, doesn't it? We tend to think of spiders as solitary, instinct-driven, but their ability to process this much data, to interpret intent, to dynamically manipulate their environment, it suggests a much deeper level of intelligence than we give them credit for.
It's an adaptable, interpretive response that is far from simple instinct. Nature shows us that immense complexity can emerge from something as simple as tension and thread. The web is both an ear and a voice.
So next time you see a spider web glistening in the morning, you have to remember the unheard dialogue traveling along its threads, conversations about food, danger, courtship. What seems so silent to us is actually a world alive with sound, a communications model we're only just starting to decode.
It's a remarkable insight, really.
It makes you wonder, though, if spiders can communicate so efficiently using just silk and vibration, if a simple protein is alive with that much sound, what conversations are happening in other things we think of as inert?
Right.
I mean, think about the root systems of a forest or the steel in a skyscraper. What other vital, unseen dialogues are going on all around us that we are just structurally deaf to? We've got a lot more listening to do.